Okay, I know that this says notes 5.1, but I'm going to move this into our unit 4 because we're still dealing with factoring here. So I think it's a good time to introduce this. So what we're going to do now is we're going to solve. Everything that we've done up to this point is we've just factored. There hasn't been an equal sign. So now we're going to solve. So remember, whenever we solve, that means we have to have an x equals at the end, or a y equals, or whatever our variable is. So we're going to have an answer. So now all of our factoring has an equal sign in here. Okay? So just an easy way to think about doing this says, what if two numbers are being multiplied and the answer is 0? So it doesn't matter, any two numbers. So 2 times 0 equals 0. Or I can say 0 times 2 equals 0. It doesn't matter. Either the first number is 0 or the second number is 0, but the answer is going to be 0 because anything multiplied by 0 is 0. It doesn't matter. And that's actually a zero product property. And we did this even back in 8th grade. It says if A times B equals 0, then either A equals 0 or B equals 0, or really truly A and B could equal 0, right? So this would be anything multiplied by 0 is always 0. And that's going to be a crucial product when we're solving by factoring, okay? So now it says, what if two numbers are being multiplied and the answer is 10? So I could say 1 times 10, or 10 times 1, or 2 times 5, or 5 times 2, right? Does this mean that either the first number or the second number must be 10? No. I mean, this example of 2 and 5, it doesn't work. So because of this, this is why when we solve by factoring, we always set the polynomial equal to 0, because we know that we can find the factors. So when we solve, this is already in factored form. So we factored this side and we factored this side, and we know that it equals 0. Well, if it equals 0, what we're saying here is that this factor, if this is 0, then that makes the whole thing 0. Or if this factor is 0, it makes the whole thing 0. So we're going to set them equal to 0. So we have x plus 2 equals 0, and x minus 4 equals 0. So when we solve this, we get negative 2, and we get positive 4. Now, what a lot of people say here, so these are my answers. Negative 2 and positive 4. I have two answers for this. And when I plug in negative 2, this equals 0. And when I plug in positive 4, this equals 0. And sometimes people say, oh, well, it's the opposite sign. Well, it is the opposite sign because it's whatever makes it 0. Okay? So this one's super simple. This one's a little more confusing because we have fractions in here. Now, it really isn't because it's the same concept. So 3x plus 1 equals 0, or 2x minus 5 equals 0. So if I solve this, I would move it over. So 3x equals negative 1, so x equals negative 1/3. That's my first answer. This one I move over, and that's my second answer. So here's what I would tell you. Be cautious, but it's going to be the opposite sign, so negative 1, and then divide by whatever the coefficient is on the x. So it's negative 1/3. Opposite, positive 5/2. Okay? If you see this and you get jammed up, just go over here and just do this on the side, right? Then you won't have any mistakes. All right, so this inside here, this is easy, right? We just did this, but now we have this 2x on the outside. There is an x here, so if there's an x, we're going to have a solution. So if I have 2x equals 0, then x equals 0 over 2. 0 over 2 is not an answer. 0 over 2 is always, it's okay, so it's always 0. So my first 0 happens at 0. When this is 0, then the whole thing is. So if I use my other strategy here, my other x is going to be opposite sign divided by the coefficient. Okay? Now, if you need to go over and do it this way, 3x equals 7, x equals 7 over 3, then go do that so that you don't make a mistake. But you need to get to the point where you can recognize it. Okay, I have 3 answers this time. So I have this answer, So this is going to be when x equals 0. I have this answer, so it's going to be when x equals -9. And I have this answer, which is going to be x equals opposite sign, so -1 divided by the coefficient. So I have 3 answers here. Okay, so let me actually, I'm going to write one down here, and let's talk about this one. So 2. All right, so here's another example. How many zeros do you think I have? I only have 2. There's not an x here. So because there's not an x here, we just don't even care about that. So my answers are going to be x equals 5 and x equals opposite divided by the coefficient. Okay, now this works no matter how big the polynomial is. So I could have x minus 2, x plus 3, 3x minus 7. I could put an x out the front. I could actually put an x squared out in the front. As long as this equals 0, you're going to use the same pattern on all of this. Okay? All right, let's turn it over. All right, so now what's going to happen, these were nice because they were already in factored form. Now what's going to happen over here is we have to factor these first. So before we factor, and this isn't a hint, this is a requirement, we have to make sure that the equation is equal to 0. So first thing I'm going to ask myself, this is equal to 0. I'm going to factor this. This is a simple one to factor. So what I have here is x minus 3 and x minus 2, right? So negative times negative is positive 6, and then I have negative 3x minus 2x, which is negative 5x. Now, this equals 0. Now, if you remember what we've done in the beginning of the unit, that's all we did was just factor it. But now that we're solving, it has to equal 0. So I have x equals 3 and x equals 2. All right. First step, it has to equal 0. This doesn't, so I have to move it over. Okay, no GCF. So I'm going to factor this. I have a positive, so I know I'm going to add. So this gives me 8 plus 5. Let's see, I wanted this to be 4. That's my 8. That's my 5. Same signs, and they're both negative. Okay, so let me check this. 4 times 5 is positive 20. I have negative 8, and I have negative 5p, which gives me negative 13. So I'm good. So when I solve this now, I get p equals 4, and p equals 5/2. Okay. I'm going to solve this. Actually, I'm going to solve this 2 ways. I'm going to solve this the way we've been doing with factoring. So what I have here is 16m squared, so perfect square, difference, perfect square. So I know that this becomes 4m plus 5 and 4m minus 5 equals 0. So my 2 values here are going to be negative 5 over 4. That's this first one right here. And this one is going to be m is positive 5 over 4. So those are my 2 solutions. Now, let me show you another way to do this. So if I have 16m squared minus 25 equals 0, I see that this is a perfect square and this is a perfect square. So I'm going to rewrite this as 16m squared equals 25. So I take this 25 and I move it to the other side. And now this is all perfect and this is all perfect. So if I take the square root of this and I take the square root of this, I end up with 4m equals 5. So m would be 5 over 4. Now, up here we have positive 5 over 4, negative 5 over 4. Well, remember, when we take the square root, we're really saying plus or negative square root of 5 over 4. So this one is kind of a unique situation. I can solve it by factoring, or I can solve it by taking the square root. Okay, I am going to pause this. I want you to finish the last 3 and then come back and I'll talk through the answers. Okay, here we go. So, first one, hopefully you saw you have to pull the -5 over, right? Or sorry, you have to move the 5 to the other side so that you set the whole thing equal to 0. Okay, let's look at number 9. Number 9 is super tricky. So I pull out a GCF. Here's what's left. I only have 1 and 5 and 1 and 3 as options, right? There's no way I can get a combination of 9 out of these factors, 1 and 5 and 3 and 1. So this part of my problem is prime. It doesn't work. However, I still have this x that's sitting out here. So because this x is out here, this is still x equals 0. So I do have a solution. My solution is just x equals 0. It's the only answer that I can have that's in here. Okay? All right, let's go over here and look at 12. So 12 starts out the same way. I pull out a GCF, but this one's factorable. So I have 2x, 2x plus 1, and 3x minus 2. So I have 3 solutions on this. Now let me give you a hint on this. When we have a quadratic, so when we have something that is to the second power, this means I'm going to have 2 solutions. And I do have 2 solutions, right? So this tells me I have 2 solutions. I'm going to have 2 solutions. Everything's going to have 2 solutions. When I get down here, this tells me I'm going to have 3 solutions, but I really don't because this is prime. All right? This is my biggest power, and so this tells me 3 solutions, and I have 3 solutions. Okay, so think about this. The power on the polynomial, the greatest power, tells you how many solutions you're going to have. Okay? So think about that as you're going through here. So that you know like what you should be shooting for. Number 9, this is a special case because that's not factorable.